Good day, viewers. We are still going to be talking on this derivative of exponential function, but there is something I really want to emphasize: differences based on this. If we have a question like um exponential sine x, let me just say y is equal to this, and we have another one to be y is equal to this. There is a difference between this and this in the solving. There's a difference between this and this. Remember in my last video, if you check my last video, I said something that if a question like this is given, is for us to pick this. When we differentiate this, we keep the answer at the back and repeat the question given. This is what I mean. That the derivative of this is, if I differentiate my sine x, the answer is cos x. Then I repeat this. That's what I said in my last video. If you can really check my last video. Now, what about a question like this? Someone just asked a question like this. So what about something like this? I'm going to answer it. Question like that, if a question like this is given, especially when it comes to this this is what I mean. I will clean this side because we are familiar with this one solving from our previous solving. We have y is equal to, my y is equal to a raised to power sine x. If you see something like this, when it start with a, apply a natural log to both sides. Just apply natural log to both sides. What did I mean? Apply log base e to both sides. Have you seen? I have applied it to both sides now. That's how you will be solving question like this. When you just see this, just apply natural log to both sides. Whereas the other one, we just differentiate the numerator, that is the sine x, and the answer was cos x. Then we repeat the question. But in this one question like this, we just apply natural log to both sides. Let's differentiate this. If you can check my previous video, I differentiate this already in my previous video. I said something that if we want to differentiate this, let's differentiate this in respect to x. We also differentiate this in respect to x. But before I differentiate this, remember that there is a law in log that says that if we have log mp raised to power p, that it is always equal to log m. So now I'm going to bring this to the back side, and automatically here become sine x log base e a. Have you seen that? That is it. I have been able to look at my p here. My p is this sine x, which is here. Look at m is this, and this is my p. So I change it to this log by bringing this one back. This is p. Look at my p here. Log. This is log, and this is m, and this is m. So I've been able to interpret that. I'll clean this, but let's differentiate now. I'll differentiate this also with respect to x. I said something that if here is p, to differentiate something like this, it will be 1 all over p dx. If here was z, it will be 1 all over z dz dx. If here was l, it will be 1 all over l dl dp dx. So now the derivative of this will be 1 all over y dy dx. Is equal to, now let's look at this. This is x, this is x. So now the derivative of sine x is what? Is cos x. So now here turn to cos x log this. So this is not the answer. The next, when we reach a stage like this, is to multiply both sides with y. I would multiply both sides with y. That will be 1 all over y, 1 all over y dy dx times y. That is my times y is equal to cos x and this times y. So this and this truncate, and we are left with dy dx is equal to, have you seen this now? I will change this my y now to the question given, because y in the question given is a raised to power sine x. So here turn to be a raised to power this into this. So that is the difference between a equation like this and this. And this one we apply natural log to both sides, then we differentiate. Alright, this one we just pick this, we differentiate the answer, and we keep this in the answer. That's the difference between this and this. Please still do more to drop another question on the comment section below for more interesting videos. If there is what you notice, just drop it on the comment section. I'm going around to check. Thank you. Bye bye.